So let me get a piece of chalk. So the first rational function we're going to graph is f of x is equal to 2x plus 3 over x squared plus x minus 6. And the first thing we got to find is the domain of this function in interval notation. Okay. Well, you know how to find the domain of a rational function. We did that yesterday. You set the denominator not equal to 0, okay? And then you solve for x, right? So this factors into x plus 3 times x minus 2. Okay. And you'll have to do this work right in the spaces around this area and around the grid for the graph. This product can equal 0. So x plus 3 can equal 0. And x minus 2 can equal 0. So we get x can equal minus 3. And x can equal 2. So in the blank here, where it says domain in interval notation, I'll write it over here. The domain in interval notation is minus infinity to minus 3, union minus 3 to 2, union 2 to infinity. Any questions on that? Now, the range in interval notation is the last thing we do. Right. We'll do that. Remember on exam 1, we found the domain and range of a function by looking at the graph. So we'll get the range after we graph the function. Okay. Equations of the vertical asymptotes. Okay. First, before we get the equation of vertical asymptotes, we have to make sure we don't have any common factors in the numerator and denominator. Well, we know the denominator factors into x plus 3 times x minus 2. And so there's no common factors in the numerator and denominator. Okay. So to get the vertical equations of the vertical asymptotes, and this you got to emphasize. It says the equations of the vertical asymptote, and so we know vertical asymptotes a vertical line, so we need the equation of the vertical lines for the vertical asymptotes. Okay. Well, no common factors in the numerator and denominator. So to get the equations or the location of the vertical asymptotes, he said each factor equal to 0. You solve for x. So we have x plus 3 is equal to 0, and we have x minus 2 is equal to 0. And when you solve for x, you get x equals minus 3 and x equals 2. So the equations of the two vertical asymptotes are the vertical lines, x equals minus 3 and x equals 2. All right, so now if you flip back to the previous page, top of page 3, we can look at the definition, okay, of vertical asymptote, okay? So f of x is a rational function, polynomial in the numerator, polynomial in the denominator. And if for some value of x, the denominator equals 0, and the numerator doesn't equal 0, right, for that value of x, then x equals that value of x is a vertical asymptote in the graph of the rational function. Okay? And so you can see at x equals -3, the denominator equals 0, but the numerator doesn't equal 0. And at x equals 2, the denominator equals 0, and the numerator doesn't equal 0. So that means we have vertical asymptotes at x equals -3 and at x equals 2. And the equations for those two vertical asymptotes, okay, are the vertical lines x equals -3 and x equals 2. Okay. Any questions on that? Okay. All right. Now, if you look at to find the equation of the horizontal asymptote, okay, you got to look at the degree of the numerator and degree of the denominator. Okay, the degree of the numerator is 1, and the degree of the denominator is 2. Right. Largest power of x in the numerator is 1. Largest power of x in the denominator is 2. And when the degree of the numerator is less than the degree of the denominator, we call that bottom heavy. And when the rational function is bottom heavy, the equation for the horizontal asymptote is y equals 0. So you can write y equals 0 in the space to the right. So we have x equals -3 as a vertical asymptote, and x equals 2 as a vertical asymptote, and then we have y equals 0 as a horizontal asymptote. Okay. And so on the previous page, where it talks about how to find the horizontal asymptotes of a rational function, that's what this first case is. If the degree of the numerator is less than the degree of the denominator, okay, we call that bottom heavy. And if the rational function's bottom heavy, then the line y equals 0 is the horizontal asymptote. Okay. So on the bottom of page 4, we can actually now graph the vertical asymptote and the vertical asymptotes and the horizontal asymptotes. X equals -3. Right, then here's the vertical line, x equals -3. And here's the vertical line, x equals 2. So those are our two vertical asymptotes in the graph of this rational function. And then the equation of the horizontal asymptote is y equals 0, and the line horizontal line y equals 0 corresponds to the x-axis. So there's the horizontal line, y equals 0. Okay. And so now we've graphed the two vertical asymptotes and the one horizontal asymptote. Next, it asks for the coordinates of the x-intercept or intercepts and the coordinate of the y-intercept. And we talked about how to find the x-intercepts and the y-intercept yesterday in class. So to find the x-intercepts, we showed in class that once you've canceled any common factors in the numerator and denominator, you set the numerator equal to 0 and solve for x to get the x-intercept. We did this on page 1 yesterday. So get the x-intercept for the graph of this rational function. We set 2x, the numerator 2x plus 3 equal to 0. And when we solve for x, we get x is equal to minus 3 halves. Okay? Well, you're instructed to give the coordinates for the x-intercept. So you got to write it as an ordered pair. Coordinates are minus 3 halves, comma 0. Okay. To get the y-intercept in the graph of this rational function, yesterday we just said you evaluate the function at x equals 0, right? Y equals f of 0 is the y-intercept. Well, we pointed out that when you put in 0 in for x in the rational function, all the terms with x in them, right, will equal 0, and you're just left with the constant in the numerator over the constant term in the denominator. So f of 0 simplifies to 3 over minus 6, which is equal to minus 1/2. So the y-intercept in the graph of this rational function, right, is the point 0 minus 1/2. And so we can plot the x-intercept and the y-intercept in the graph of this rational function, right? So I have provided you with a grid. So here's the vertical line, x equals 2. And here's the vertical line, x equals minus 3. And then the horizontal line, y equals 0, corresponds with the x-axis. Okay. The x-intercepts at minus 3 halves 0. So here's minus 1, here's minus 2. Minus 3 halves is the same as minus 1 1/2. Right? So there's the x-intercept. And then the y-intercept's at 0, minus 1/2. So if this is minus 1 on the y-axis, here's where the y-intercept is, right? Halfway between the origin and y equals minus 1 on the y-axis. And now we can proceed to graph this rational function. Okay? We know the x and y asymptotes, and we know the x and y intercepts. Okay? All right. So just to remind you, f of x is equal to 2x plus 3 over x squared plus x minus 6. Okay? Which factors to 2x plus 3 over x plus 3 times x minus 2. Now, For each asymptote, okay, each vertical asymptote, we got to decide on each side whether the graph goes up or goes down, right? And so what you do is you take a value of x just to the right of the vertical asymptote, and you see whether the value of the function is positive or negative. And the value of the function is positive, the graph goes up. If the value of the function is negative, the graph goes down. Okay? So we know that, so let's do the middle part first, okay? So we know the graph is going to cross the x-axis right here. And we want to know, is the graph going to go up or go down to the right of this vertical asymptote? Well, we can test the value of the function at x equals -2, and the value of the function is positive, the graph's going to go up. If the value of the function is negative, the graph's going to go down. Okay. So f of -2 is equal to, now you can either do unfactored form or factored form, okay? You're not really interested in the value of the function. You're just interested, is it positive or negative, okay? So when you put in -2 for x, you have 2 times -2 plus 3 over, I'm using the factored form, -2 plus 3, -2 minus 2. Numerator, -4 plus 3 is -1. -2 plus 3 is 1. So we have 1 times -4, which is -4. And so this is equal to 1/4, which is a positive number, right? So the value of the function is equal to 1/4 at x equals -2. So that means the graph is going up, right? On the right-hand side of this vertical asymptote. So the graph has to look something like that, okay? To the right of that vertical asymptote. And now you can deductive reasoning, you can deduce that the graph is going to cross the y-axis here and then go down. It can't go back up on the left side of this vertical asymptote or across the x-axis and create another x-intercept. And there's none there. Okay. But we'll test the value of the function here at x equals 1. Right, x equals 1 is between the y-intercept and x, the vertical asymptote, x equals 2. And so when we evaluate the function at x equals 1, we have f of 1 is equal to 2 times 1 plus 3 over 1 plus 3 times 1 minus 2. I'm using the factored form here again. Okay? And so we get 5 in the numerator. 1 plus 3 is 4. 1 minus 2 is -1. 4 times -1 is -4. And 5 divided by -4, right, is negative. So that means that the graph goes down to the left of the vertical asymptote, x equals 2. So the graph is going to cross the x-axis here, cross the y-axis here, and then go down. So that's what the middle part of the graph looks like. Okay. Now we got to figure out what the graph looks like to the right of x equals 2 and to the left of x equals -3. Well, we do the same thing, right? To the right, on the right side of the vertical asymptote, x equals 2. Okay. So y equals 0, the x-axis is the horizontal asymptote. So we know the graph is going to flatten out on the far right end, okay, either above the x-axis or below the x-axis. Okay. So we just got to do a test point, like at x equals 3, to see whether the value of the function is positive or whether it's negative. to see whether the graph goes up or goes down to the right of that vertical asymptote. So when we evaluate the function at x equals 3, you have f of 3 is equal to 2 times 3 plus 3 over 3 squared plus 3 minus 6. 2 times 3 plus 3 is 9. 3 squared plus 3 minus 6 is 6. And 9 divided by 6 is positive. And so the graph goes up to the right of this vertical asymptote. And so the graph goes up to the right of it, okay? And because the x-axis or y equals 0 is a horizontal asymptote, we know that it's got to flatten out going to the right above the x-axis. Any questions on that? So to determine whether the graph goes up or goes down on each side of the vertical asymptote, you got to do the test. Okay. Now, to the left of x equals minus 3, right, is the number minus 4. So let's evaluate the function at x equals minus 4. And we have f of minus 4 is equal to 2 times minus 4 plus 3 over minus 4 plus 3 times minus 4 minus 2. Again, I'm using the factored version of f of x. Okay. 2 times minus 4 plus 3 is negative 5. Minus 4 plus 3 is negative 1. Minus 4 minus 2 is minus 6. And negative times negative is positive. So we have negative over positive, which is negative. So the graph goes down, okay, to the left of this vertical asymptote. Okay? And because y equals 0 is a horizontal asymptote, okay, it's got to flatten out going to the left. Okay? So that's what the graph of this rational function looks like. Okay? Any questions on that, ladies and gentlemen?